Welcome to the 8th video on solving equations, and in this video we will solve equations involving modulus or the absolute values of x. So first things first, what is the meaning of modulus of x? So modulus of x, if you are not aware, is written in this fashion. We read it as mod of x, and this is a function which later on we will also cover under the category of functions. But for now, you've got to understand that mod of x can have two possible values. Mod of x will be equal to minus x if x is less than 0, and mod of x is equal to plus x if x is greater than equal to 0. For example, I want to calculate the mod of minus 2. Now, the first thing you've got to see is whether minus 2 is less than 0 or greater than equal to 0. Obviously, minus 2 is less than 0. So how do you define mod of x when x is less than 0? You define it as minus x. So we will write it as minus of minus 2, which is equal to plus 2. What about mod of 3? Mod of 3, since the value of x is greater than equal to 0, you will write it as 3 itself. So one thing you've got to understand is that whatever you put inside the modulus operator, when you open the brackets, you're going to get a positive value here. Now with this basic understanding of modulus, let us proceed to the equations. And there is a set method with which you are going to solve the equation. For example, if there is an equation of the form of mod of x plus minus a is equal to, let's say, c, where a and c are some constants, a और c कोई constants हैं, तो ऐसी इक्वेशन को सॉल्व करने के लिए आपको दो केसेस लेने पड़ेंगे. केस नंबर 1, उसमें आपको बोलना पड़ेगा कि ये ओपन करो ब्रैकेट, आप मॉड ओपन करो और सीधे लिख दो x प्लस ए इज इक्वल टू सी. ये केस 1 है. केस 2 में ये नेगेटिव क्वांटिटी हो सकती है, तो इसलिए यहाँ पे माइनस ऑफ x प्लस ए इज इक्वल टू सी. तो ये दोनों केसेस को अज्यूम करके हमें इक्वेशन को सॉल्व करना होगा. ये ध्यान रखना, यू गॉट टू अज्यूम दीज टू केसेस in order to solve the equation. For example, if I have an equation like mod of x minus 5 is equal to 4. So the quantity inside the mod can be less than equal to 0 or greater than equal to 0. This part is clear. So first let us say that the quantity inside the modulus operator is greater than equal to 0. So what happens to the mod if x is greater than equal to 0? You can remove this mod bracket and write simply x. So whatever is inside this mod, you can write the same thing. Like case 1, I remove this mod and I'll write simply as x minus 5 is equal to 4. So x is equal to 9. So this is the first case. Case 2, it is quite possible that the value of x is less than 0. If x minus 5 is less than 0, I'll have to open the mod bracket and write it as minus of x minus 5. So minus of x minus 5 is equal to 4. So minus x plus 5 is equal to 4. Minus x is equal to minus 1, or x is equal to 1. So there are two possible values of x. X is 1 and x is 9. It's always a good habit to substitute and find whether the answer is correct or not. Let us put x is equal to 9 in this. So what do you get? Mod of 9 minus 5 on the left hand side, which is equal to mod of 4. Now since 4 is a positive quantity, I will simply write 4 as 4, mod of 4 as 4. Similarly, if I put x is equal to 1, I'll get mod of 1 minus 5 on the left hand side, which is equal to mod of minus 4. Now since this is a negative quantity, I will write this as a minus of minus 4, that is equal to 4. Since both the values satisfy our answers, both the answers are acceptable. So x is equal to 9, x can also be equal to 1. So let us solve a similar equation. And by now you would have realized कि करना क्या है. आपको इस ब्रैकेट को ओपन करना है, एक बार 2x plus 5 लिखना है is equal to 3. And in the next case, just put a minus sign and put 2x plus 5 in a bracket. So minus into parentheses into brackets 2x plus 5 is equal to 3. So this is your case 1, this is your case 2, and solve the equation for both these cases, case 1 and case 2. So let us do that. Case 1. 2x plus 5 is equal to 3, which means 2x is equal to minus 2 or x is equal to minus 1. So case 1 will give me minus 1 as the answer. Let us put that into this equation and see whether we get 3 as the answer. 2 into minus 1 is minus 2, plus 5 is minus 3, and mod of minus 3. Since minus 3 is less than 0, I can write it as minus of minus 3, which is plus 3, which is equal to the right hand side, and therefore this particular value x is equal to minus 1 is an acceptable solution. Case 2. केस 2 में हमको क्या करना है, that we put a negative sign outside this 2x plus 5. So minus whole into bracket 2x plus 5 is equal to 3, which reduces to minus 2x minus 5 is equal to 3, which reduces to minus 2x is equal to 8, or x is equal to minus 4. So we get another set of value for x, another value for x in fact. So again, put x is equal to minus 4 here. We get 2 into minus 4 mod plus 5 on the left hand side. So minus 8 plus 5 is minus 3 on the left hand side, and mod of minus 3 is equal to 3, which is equal to the right hand side. So both values of x, minus 1 and minus 4, are acceptable values in this particular case. So all you need to remember is, while solving a modulus equation of this kind, you open the mod operators, first time write the expression as it is, and in the second case put a negative sign outside the expression and solve it as another equation. Let us see some more questions. So now we have mod of x minus 5 is equal to mod of 2x plus 3. Now there are two mod operators. So what can we do? Both sides can be greater than 0. Case 1. Both. Suppose this is a and this is b. So a comma b both are greater than 0. In which case I will open these brackets as x minus 5 and 2x plus 3 respectively. Case 2. Both a and b are less than 0. In which case I will open this bracket as minus x minus 5 and this bracket as minus 2x plus 3. Correct? Now this is very important for you to understand. Case 3. A is less than 0 but b is more than 0. If a is less than 0, I will simply have minus x minus 5, but b I will open as it is 2x plus 3. And case 4, what is that? A greater than equal to 0 but b less than 0. In which case I will open a as it is x minus 5, but I will write minus of 2x plus 3 for b. So this will give me 4 possible values of x, and I have to put that back into the equation as we always do and find out whether the values satisfy. Let us take the first case. In the first case, both of them are greater than 0. So I can simply write it as x minus 5 is equal to 2x plus 3. This is your case 1. So which implies x is equal to minus 8. Now does x is equal to minus 8 satisfy? If x is minus 8, you will get minus 8 minus 5, minus 13 on the left hand side, and 2 into minus 8, minus 16 plus 3, minus 13 on the right hand side. And because they are both enclosed in a modulus, therefore this will be equal to 13, 13 on both the sides. So x is equal to minus 8 is definitely a solution. Now, if you consider the next case, minus case 2, minus of x minus 5 is equal to minus of 2x plus 3. Will it give us another solution? Because I can write the same equality by taking 2x plus 3 on the other side and x minus 5 on the right hand side. So minus 2x plus 3 on the left hand side will become simply 2x plus 3, and minus of x minus 5 will simply become x minus 5. But if you see this equation, this one, it is the same as your condition number 1, and hence will give us the same answer. So we don't have to worry about solving this equation. Now let us take the second case, third case in fact, a less than 0 and b greater than equal to 0. If a is less than 0, so you will have a minus sign outside x minus 5. So minus of x minus 5 is equal to 2x plus 3. So minus x plus 5 is equal to 2x plus 3. So 3x is equal to 2. So x is equal to 2 by 3. Now is this an acceptable solution? Once again, put the value of x in LHS and RHS both. Putting the value of x in LHS, you get 2 by 3 minus 5 in LHS, right? So 2 by 3 minus 5 is minus 13 by 5, which is obviously 13 by 5. And put the same value of x as 2 by 3 into RHS. What do we get? 2 into 2 by 3 plus 3, which is again mod of 13 by 3, and which is equal to 13 by 3. So you can see that LHS and RHS are equal and equal to 13 by 3. So there are two possible values of x is equal to 2 by 3 and x is equal to 13 by 3. With this, we come to an end of this session. If you have any further queries, please feel free to approach your tutors.